Hi guys, in this video we're going to be going over the product rule and the quotient rule when it comes to derivatives. So yeah, let's get right into it. Alright, I have the product rule here. So the product rule is useful when you have a function which can be expressed as the product of two other functions. So we have d dx and the function inside here is f of x times g of x. And the product rule states that that derivative is equal to f prime of x. Remember, f prime of x is simply the derivative of the function f. So f prime of x times g of x plus f of x times g prime of x. So the derivative of the function f times the normal function g of x plus the original function f of x times the derivative of g of x. So I have an example here. So you have a function h of x, and that's equal to x squared times cosine of x. So what I'm going to do is I'm going to let f of x equal x squared, and I'm going to let g of x equal cosine of x. Now what I can do is I'm going to find the derivative of f of x and the derivative of g of x. So the derivative of x squared is 2x, and the derivative of cosine of x is minus sine x. So now I'm going to bring that all together. So I'm going to calculate the derivative of the function f, so h prime of x, and that's going to be equal to d dx of x squared times cosine of x. Now remember, we set f of x equal to x squared and g of x equal to cosine of x. So we can actually replace x squared with f of x, and we can replace cosine of x with g of x. And now using the product rule, so remember the product rule states that the derivative of f of x times g of x is the derivative of f of x times g of x plus f of x times the derivative of g of x. So I'm just using that same rule here. That's the product rule right there. Now I'm just going to substitute the values. So f prime of x is 2x, and g of x is cosine of x. F of x is x squared, and g prime of x is negative sine x. And so that's the resulting value. And we're just simplifying here, taking the negative, and yeah. So the final answer is 2x cosine of x minus x squared sine of x. And that's the derivative of this function here. Now I have a proof for the product rule here. And this is a quite simple proof, so I thought I might as well write it. Alright, so up here we just have the derivative of the definition of the derivative here. So d of x of f of x, so the derivative is the limit as h approaches 0 of f of x plus h minus f of x over h. So this is the slope, and we're asking ourselves, what does the slope approach as the distance between the 2 points on the secant reduces or approaches 0? So that's the definition of the regular derivative. Now what I have here is I have the derivative of f of x times g of x, and I'm just using this definition up here, and I'm using it for f of x times g of x. So putting x plus h into this function here would give f of x plus h times g of x plus h, and putting x into this function here would give f of x times g of x. So this is just the same derivative definition, but I have a different function here, which is the product of two functions. So it's the same thing. All right. So now what we're going to do is we're going to do a little bit of algebraic magic. So we're going to copy. I'm copying this over here, but I'm adding two extra terms. I'm adding this minus x plus h, minus f of x plus h times g of x, and I'm adding this plus f of x plus h g of x. You can see that we're minusing and plusing the same value, so the value of this expression doesn't change, but we have two new terms, which now we can work with the whole expression algebraically. So what I'm doing here is so let's look at this half first. So these two terms. So I'm going to take out the f of x plus h, and I'm going to take that out because it's a common factor between these two terms. So I'm taking out the f of x plus h, and we're left with g of x plus h minus g of x over h. So I took out these two f of x plus h, and now we just have g of x plus h minus g of x over h. So that's that one right there. Now we're going to worry about this half. So you can see here we have a common g of x. So I'm going to take out that g of x. So I have that g of x right there. I'm going to times what's remaining after we take out g of x. So it's going to be f of x plus h minus f of x over h. So that's what we have right now. And now, using our limit properties, we know that the limit of a product is the same as the product of the limits. So I'm going to take out this f of x plus h here. I'm going to take it out and put it as its own limit. So I have the limit as h approaches 0 of f of x plus h. And I'm timesing that by the limit as h approaches 0 of g of x plus h minus g of x over h. So this expression right here is the same thing as this expression right here. And similarly, I'm doing the same thing here, taking out the g of x, putting it in its own limit, and we're taking the product of those two limits, which is the same as this expression here. All right, so now we can evaluate these limits. So let's evaluate this first limit, the limit as h approaches 0 of f of x plus h. So here we can just substitute h as 0, and that will actually give us just f of x. So as h approaches 0, f of x plus h approaches f of x. The second limit here, you might recognize it, it's just the definition of the derivative. So the definition of the derivative up here is this one right here. And here we just have the definition of the derivative for g of x. So that is g prime of x right there. And here we have the limit as h approaches 0 of g of x. Now, g of x doesn't even contain the letter h, so we can just put g of x here. G of x isn't affected by h. And finally, we have this final expression, the limit of as h approaches 0 of f of x plus h minus f of x over h. And that is simply the definition of the derivative for f of x. So we have f prime of x there. So the final output we got was f of x times g prime of x plus g of x times f prime of x. And just rearranging that and putting it as its own formula, we have the derivative of f of x by g of x is equal to f prime of x times g of x, that's that one right there, plus f of x times g prime of x, that's that one right there. So that is the complete proof for the product rule. Okay. Let's now move on to the quotient rule. Quotient rule is a little bit more complex. Well, not really. It's just there's a lot more terms to think about. So the quotient rule, we have the derivative of f of x over g of x is equal to f prime of x times g of x minus f of x times g prime of x, and all of that divided by g of x to the power of 2. So it might feel a little bit contrived at this point, but let's go through an example so we can get a little bit more accustomed to it. So I have this function here, h of x, it's equal to the natural log of x divided by the cosine of x. So I'm going to let f of x equal to the natural log of x, and I'm going to let g of x equal to the cosine of x. Now we're going to take their respective derivatives. So the derivative of the function f is 1 over x, and the derivative of the function g is minus negative sine of x. All right, so now we can use the quotient rule. So we have h prime of x is equal to the derivative of h of x, and we're going to set that equal to the derivative of f of x over g of x. So we have defined f of x and g of x over here. Now this right here is the quotient rule, so we're applying the quotient rule. So f prime of x is equal to 1 over x. G of x is equal to cosine of x, so we have that one right there. Then we have minus f of x, so the natural log of x. Then we have times g prime of x, which is negative sine of x. That's what we have right there. So now what I'm doing is I'm just simplifying this expression. So let me put that up right there. All right. Okay. So I have this expression here. And now what I'm doing is I'm taking this part of the piece. So 1 over x times cosine of x is going to be cosine of x over x. And then we can cancel out the cosine. We can cancel out 1 cosine of x on both the numerator and the denominator. And we'll have 1 over cosine of x, I think. Oh wait, actually, where did our x go? Oh my, okay, I think I've made a mistake there. Yeah, but so you just simplify this and you'll get the final derivative. I think I have to fix something up here, but yeah, that's the quotient rule. That is the basic premise of the quotient rule. And that's it for this video. Thank you for watching.